Hey there, Geometry. Thanks so much for tuning in with another episode of Math with Mullins. Today we're going to be looking at Lesson 2.6, Part 1 or Day 1, and how to prove geometric relationships. Our main idea today is to be able to look at those geometric relationships, but then able to write a flowchart proof, which I personally like better than paragraph proofs, to figure out how those relationships are proven. So if we look at our first part of our notes, it says another proof format is a flowchart proof or flow proof, which uses boxes and arrows to show the flow of a logical argument. Each reason is below the statement it justifies. So what we're going to try to do is use the reasons A, B, C, and D and try to determine where they should go. So it says, given that AC is equal to AB plus AB, prove AB is equal to BC. Well, the first bubble we have is AC is equal to AB plus AB. That is our given from right here in the very beginning of our problem. The next portion, we have AB plus BC is equal to AC. That is the segment addition postulate. So that would be going here. Segment addition postulate 1.2. Okay. Then we are translating over here to AB plus AB is equal to AB plus BC. This one is the transitive property, just because now we're saying that AB is equal to BC. So that would allow us to say that this last one is the subtraction property of equality, because we have subtracted AB from both sides to give us AB is equal to BC. Okay, so sometimes we're given opportunities to plug in. So that's what we're actually going to do on this next part. So this next example, I want to see if you can try to pause it on your own, see what things you can fill out first by yourself, and when you're ready to check it, go ahead and click play. All right, our given is the measure of angle 1 is equal to the measure of angle 3. So we're going to write given in that box there. And as you go through these, you can also cross them off your list. Underneath that is where we're going to start connecting what is EBA. So if we look at EBA, EBA is the measure of angle 2 plus the measure of angle 3. Really, for this one, you could have done A, the angle addition postulate, which is postulate 1.4. But if you also wrote D, because you notice how you have those twice, A or D would work here. So I'm just going to say I put A for that first one. Then if we continue, it says the measure of EBA can also be equal to the measurement of angle 2 plus the measurement of angle 1. Okay, for that one, we would use the substitution property. So that would be letter C. The reason is because both angle 1 and angle 3 are equal. So notice how I just replaced angle 3 now with angle 1. Then, as I go on through my flowchart here, the measurement of angle EBA is still now equal to the measurement of angle 1 plus measure of angle 2. That's just when we flipped around measure of angle 1 plus measure of angle 2. So that would be F, the commutative property of addition. Then going right down here, how do we get the measurement of angle EBA is equal to measure of CBD? Well, if we look at the measure of angle 1 plus angle 2, that would be, again, the angle addition postulate. So if you put A for the first one, you could put D for this one, or vice versa. So that now we can use the transitive property of equality, because the measure of angle 1 plus the measure of angle 2 is equal to EBA, and EBA is now equal to CBD, because angle 1 plus angle 2 is the same thing as angle 2 plus angle 3. So this one would be option B. Okay, hopefully you did okay here. Let's keep going and see, what does it mean to have right angle congruence? So when we see this theorem, theorem 2.3, that just means all right angles are congruent. That's the next piece of paper that you want to fill in, or next blank you want to fill in on your piece of paper. We can look at proof example 1 on page 106 if you'd like to, and if you want to do that, you can take time now to pause the video. Otherwise, if we're ready to go on, let's go ahead and look to see what we've got. Using the given flowchart proof, write a 2-column proof of the right angle congruence theorem. So now what we're going to do is use our flow chart already and write some statements and reasons. Okay, so the given is angle 1 and angle 2 are right angles. So that's the very first thing we're going to write down. Angle 1 and angle 2 are right angles. And the reason for that is because it's what's given to us. Then it says measure of angle 1 is equal to 90, and so is measure of angle 2. So we can write that in our statement here. The measure of angle 1 equals 90 degrees, and measure of angle 2 equals 90 degrees. That is the definition, here's our reason, of a right angle. So definition of right angles. Okay, going on. Now it literally it's just given us exactly what to write down. The measure of angle 1 is next, is equal to the measure of angle 2. That is the transitive property of equality. Okay, so now that we know that the measure of angle 1 is equal to the measure of angle 2 because of the definition of right angles, then we can decide that these are congruent angles. So we would say angle 1 is congruent to angle 2, and that is the definition of congruent angles, okay, which is what we just discussed in the previous slide. So next what we're going to look at, this is where you're going to try it. It says copy and complete the flowchart proof, then write a 2-column proof given that line segment AB is perpendicular to BC, then DC should be perpendicular to BC. And we just want to prove that angle B is equal to angle C. Okay, so let's take time now to pause the video here, try this one on your own, and when you're ready, click play. All right, our given statement is AB is perpendicular to BC and DC is perpendicular to BC. So we're going to write that down first. AB, perpendicular sign upside down T to BC, and DC perpendicular to BC. This is our given. Okay. The next part kind of gives us what we should be doing right here. The reason is the definition of perpendicular lines. So definition of perpendicular lines would be next. But what we want to put in here is why these are perpendicular. And the reason is because we see two angles marked. Angle B and angle C are 90-degree angles, or they are right angles. Okay? Because of that, we know that now, since we're using that definition of perpendicular lines, angle B is congruent to angle C because all right angles are congruent. Again, using that congruent theorem with the right angles. Remember, this was congruent theorem 2.3. Okay. Going on to, if you see a few more congruent theorems, we have 2.4, which is a congruent supplement theorem, and you have this definition almost all written for you. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. So you see how angle 1 and angle 2 are adding together to be supplementary. So that means angle 1 and angle 3 are equivalent or congruent. And then the same thing is true for the complements theorem. If two angles are complementary to the same angle or to congruent angles, then they are congruent. So if we have angle 4 and angle 5 are complementary, and 6 and 5 are complementary, that means angle 6 and angle 4 are congruent. Okay? Just make sure you have those two lines filled in with the word congruent for both of those, and we will try one more example. This one we might have to squeeze just a little bit on our paper. So it says, use the 2-column proof to write a flowchart proof that proves that two angles are supplementary to the same angle are congruent. So angle 1 and angle 2 are supplementary, so that means 3 and 2 are supplementary. Sorry about the bell. So we just want to prove that angle 1 is congruent to angle 3. Now, the nice thing is all of our statements and reasons are given to us. We just have to write down our givens. So let's start here. Or we have to write it down with that flowchart piece. So let's start with angle 1 and angle 2 are supplementary. and so are angle 3 and angle 2 supplementary. So that's where we're going to start. Just because we have two statements here, we're going to make sure we provide both statements, okay? Both of these are the givens. Okay, now we can go onward to the next piece. The measure of angle 1 plus the measure of angle 2 is 180, and so is angle 3 plus angle 2. So we would just write that. The measure of angle 1 plus measure of angle 2 equals 180. Boop, boop, boop. And then the measure of angle 3 plus measure angle 2 also equals 180. This is the definition of supplementary angles. So we can just write def of sup. Okay, continuing down the flowchart, we now can say, since we have both 2's on here, if we subtracted measure of angle 2 from both sides, we can now say that the measure of angle 1 is now congruent, equal to the measure of angle 3. And the reason we know that is we use the subtraction property of equality. So that we can now say the measure of angle 1 is congruent to the measure of angle 3. And that is using the congruent angles. So definition of congruent angles. Okay, that is going to conclude our notes today on lesson 2.6. Thanks so much for tuning in, and we will catch you next time.